kind words. Good morning. Yes, it is a great pleasure being here in Thessaloniki once again. And as we're going to be rolling on our technical sessions, I hope you have the opportunity to learn and share knowledge. That's the idea. And from my end, I have the pleasure to present some of our recent work that we are performing within a European project. It is called REMED. You see, it's a collaborative effort of 9 partners from 5 European Union countries. And we just completed the first year, so it's an ongoing project. I'm going to share with you some of the information that might be relevant to position what we're doing, maybe intrigue some interest, generate some interest so that you can follow it up. So if you look at, or if you just pay attention to the keywords that we had at the beginning, let's come to an agreement that, yes, we do have a problem. We do have a problem that we need to address. Sometimes we give it different buzzwords, different keywords in terms of climate change, climate crisis, and so forth. But we do have evidence that indeed the way things are going in terms of the human activities, the impacts we have on the environment, result to really significant changes and events. So, who's to blame? Well, we said humans, us. But sometimes we just don't like to point the finger at us, so we say the buildings. As if the buildings exist not to serve us. So it is the occupants living and working, us, in buildings, where because we consume a lot of energy, and the wrong form of energy, we have environmental impacts. You know these numbers, and over the decades they remain the same. About half of the energy that we use goes to the buildings. About a quarter of the emissions as a result of using fossil fuels and so forth originate from the operation of the buildings. And if you add construction, that raises and that builds about to 35%. Wow. So we do have a problem. We know, and from the engineering point of view, once you know the problem, then you look for solutions. So this is how things will look in the future. We are on a trajectory, on a trend to really resolve the issues, reduce our energy consumption, and you have heard this, as we reduce our energy need, by 2050, we're aiming to really have very small amount of energy, not zero, but very small amounts of energy that will be balanced by ways to either remove or absorb carbon from the atmosphere, so the net balance would be zero, but we're still going to be consuming some energy. And who's going to be playing really a key role? Our buildings. If we're going to be successful in this downward trend, we need to make sure that our buildings respond. All right, so that's the picture. I have the power. And right now, I'm just going to take you to the future. Take you to 2025. It is today, 2050. Almost zero energy use our buildings. Okay, so that's what we need. Are we done? Well, let me now tell you, not really. Because all the damage we have done, all the emissions we have been pumping over decades to the atmosphere, guess what? They're going to be there for years and decades. So the damage we have created, it's not going to be solved overnight, regardless of what we, with my magic rod, could have been able to do today. So we have to be prepared. We have to adapt. We have to be able to handle the issues and the damages and the problems that we can expect and we are actually experiencing today and in the future. In that, we're going to be seeing disasters, we're going to be seeing hazards, we do have to control the exposure and our vulnerability to all these events. In that preparation, and when we refer to the natural hazards, what are we going to be experiencing? We're going to be experiencing more intense, we're going to be experiencing more extreme, we're going to be experiencing more frequent issues, problems, and events. What these may be, well, you all know. Well, we are all, no matter where we live, in Greece, we're experiencing, and a lot of people say, well, you're suffering because you're down south, heat waves. But we're also suffering from extreme cold waves. We're also suffering from snowfall. Over the last decade or so, even in Athens, almost every year, every winter, you have snowfall. So extreme events that actually go from one to the hot to the cold, from the rain to the dry spells, and that have also impacts to various other activities, agriculture, and so forth. So, the key word, the underlying word, is we need to be prepared. Now, in terms of preparing ourselves, we need to look at our urban environment. So, we need, regardless of all the situations, be prepared and anticipate and find ways to respond to these events. So, now the question is, God, this is a complex issue. How are we going to do all this? How do we decide, and then also, how do we assess, first of all, where we are, and where and how much we need to improve? Not a straight answer, not an easy problem to resolve, and that complexity demands organizing a very systematic approach and engaging different experts. Now, the first step is, when we're looking at our urban environment and our cities, is to look at the specific elements, the buildings. So if we start with our buildings, then we multiply, we grow, and we can cover the urban areas, the cities. Now, already, let's realize that we have initiated this path and this effort. And all the good things that we're doing in terms of high-performance buildings, sustainability, and so forth, actually serve the other mission that we have. Why? Because if you have a high-performance building, which means a low energy demand, and also reducing environmental impacts, blah, 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 that's good, but a high-performance building can be more resilient. It can really withstand and operate and serve us even without external energy, or a very small amount of energy, which means that we can provide backup, for example, to cover our needs. So, indeed, already high performance and sustainability serve in this, our efforts in this direction. By the way, already within an ASHRAE standard, that's one of the very high exposure standard that ASHRAE has. It's 189.1. It's the famous ASHRAE standard for green buildings. Already, if you notice there, the idea and the concept of resiliency is included, specifically addressing issues and how do you handle when you have problems with nearby wildfires, and how does your ventilation system need to actually react to such situations. So, moving forward, we have already a method, a tool, that for us within this project constitutes the existing know-how. An open method, an open tool that actually helps users assess sustainability. Sustainability, as we said, is one good element of all these efforts that we want. How does that work? Well, it has a tool, it has a very well organized method, and it uses, as these systems actually work with, indicators. The indicators that we need in order to quantify the problem, the issues we need to face and resolve. So that way you can then monitor, assess your existing condition and monitor how you can improve and assess different scenarios and so forth. So in our world and the work that you're doing, you're very well experienced with an indicator that says energy use per unit floor area. These indicators actually tell you how good or how bad a building is performing. So that's a good example of an indicator. And there is a multitude of different indicators in terms of air quality, in terms of other activities of weather, performance, and so forth. So that's the idea. That's something that we already have, that's already available. It's an open method, open system, open tool that can be used to both assess the sustainability of buildings and then of cities. Now, within the concept that needs to be worked in order to perform this kind of analysis is that how do you put then on the same table, how do you handle different indicators that are not comparable, not in terms of the physical quantities, not in terms of the units, not in terms of the characteristics of these indicators. You have to put them on a common basis. So within these systems, you need to normalize and you need to benchmark these indicators so that you can all come on a common basis. So if you have, for example, in terms of a building and its power performance, the higher efficiency it has, the higher score it gets. If it's a low performance and the value of the indicator, then it gets a lower score. But it also can work the other way around. For example, you want less is better. You want a lower value of an EUI, energy use performance, then you get a higher score. If you have a high energy consuming building, you get a lower score. So that's the example of how different indicators, different physical quantities, different units can all then be translated on a common scale and used. And then once you have that score, you also then need to put different weights, different importance thing on the elements that you're assessing. Some cases, energy use may be more important, so you increase your weighting factor. Sometimes something else may be. That is then again hidden within the practical aspects of the approach. Now, once you get these tools, you don't need to do any of this work because this is done. This is in the background and behind and already coming with the knowledge that you get. So, and using this idea, we now carry it from sustainability to assessing what we said before, the resilience of our buildings and of our cities. So now we are using different types of indicators, and here giving some examples that you can assess. For example, the extreme temperatures. For example, other characteristics of an urban area, how many green areas and the amount of land that you have, open parks and so forth, that improve both in terms of reducing temperature, both of being able to absorb rainfall and so forth, and of course, whose impact this are the people and how much or how many people you have in that area. Putting it all together, then in the same similar fashion, you can actually articulate the work and be able to help. Also, at the starting last year, what we did is not start from zero. So that was our existing know-how, but we also looked what other systems, methods are out there available in the market. So this is the result. So you see there are about 180 indicators that different methods, different approaches actually utilize in order to be able to address the resilience. And you see the different hazards that we have. Again, in terms of the importance, heat waves, flash floods, and droughts are the specific hazards that attract most attention. Also, what we have available as existing knowledge is efforts that are being performed at the EU level, where every member state actually goes through the exercise. We do have a problem, let's try to face it. So they call upon each member state of the European Union to perform and make an assessment of what are the issues that they're facing today. And you see here the most important hazards as a response from the member states to the EU. And what is first? Changing temperature, heat waves, precipitation, and high rainfall events. And at the same time, don't forget the different extremes. We get too much rain because we all of a sudden get all the water in a very small time frame. We get floods, and at the same time we're complaining of droughts which have different implications. Again, how do you handle these different extremes, which of course need different ways of addressing them? Now, within these plans that each EU member state is performing, they also ask them, okay, what do you see coming into the future for your area in terms of projecting and expecting higher implications? And the big response from all of them, don't expect things to get better. Things will get worse. So again, in terms of the priorities, there is some kind of information of what we need to address. So within the work that we're performing, where are we? We are defining, as we speak, these indicators, so that's why I didn't get into the details. That's why I gave you the example of what we already had in terms of assessing sustainability. So that's where we are. We are also defining our benchmarks in order to make them practical. All this information is going to be compiled within a tool that will be open, available, so that if you're interested, you will be able to access it and use it for free. And it will be primarily of interest for municipalities that need to be able to have something practical that they can use in their complex work, and of course for you as professionals in order to be able to support this type of work. How we're going to make sure that this is going to work? We're going to be performing case studies, pilots, so that we will validate the method, validate the tools. In Greece, the National Observatory of Athens is actually, it's one of the technical scientific partners. We're collaborating with another partner, Municipality of Philis. It's on the west side of the metropolitan Athens area, where in Greece we are actually going to be performing our pilot and see how it works. See how all this is going to be performing in the field. There's going to be training material. There's going to be information that you can access, understand better what are all these complex issues. And all this is going to come into a decision support framework. So it will have the structure that you can take it, you can implement it in order to make or handle these complex issues. So a lot of good things are coming up. I've provided here some bibliography from you if you're interested, especially for what is available. As I said, this method for assessing sustainability is available. You can access it. Some of the information for our Greek audience is also available in Greek, which is important. Sometimes the language can be an issue, but most important, the information is adapted. So we have a tool for assessing sustainability of buildings and of cities available in Greek with all the adapted indicators and so forth. And hopefully, by providing this project link, you would be interested to learn more, follow more as we mature the work and as more results become available. Thank you so much for your attention, and hope you enjoy the rest of the conference, and thank you for attending.